Next speaker is Professor Ken Herrmann, who's a nuclear medicine physician at the University Hospital Essen in Germany, global leader in Theranostics, who's going to give us a talk on next generation targets. Thank you, Ken.
Thank you very much, Arun. This is a fantastic session. Marisa, I loved your slides, but I still hope that the conclusion slide showing 52% red is not indicative for any other important elections here. Again, European perspective, sorry to make the statement. So these are my disclosures, haven't changed since yesterday. We have heard a lot about how nuclear medicine has actually evolved since 1940s. And there's actually quite some time where not much happened. And it's not true. Actually, a lot have happened, but we didn't really make it through the clinic. And one of the reasons was, I think, that we answered questions nobody asked. And when I talk about new targets, I thought about what are actually questions which potentially could be answered with new targets. And these are the areas of high unmet clinical need. And of course, you're not very surprised that I mentioned the neuroendocrine differentiated tumors. We talk about also quite some tumors, around 15% probably, who are non-PSMA expressing in prostate cancer. We do have tumors who do not respond or do not respond enough or long enough to PSMA-reliant therapy, and we do have the challenge of tumor heterogeneity. And this being said, when you need to look for ideas, I usually go to clinicaltrials.gov and look what's going on. And this is a summary of a couple of targets which are currently under investigation in the space of prostate cancer. We all know I have only 10 minutes, which means I have 8 minutes for content. So I figured I should focus on 4 of them, 2 minutes each. And the ones in red are the ones where we do actually have already some clinical information, or at least they're already in clinical translation for therapy. And then 2 other ones in yellow where we only have like single information, but I'll show you a couple of examples where we are currently working on. Okay, HK2 map is actually a very interesting antibody, also called human kallikrein 2 and 3. The antibody initially comes actually from academia. David Ulmert is out-licensed to Janssen, and one of the problems with industry is that they do studies very, very nicely, but we have very little information which I can share, at least which I can share without breaking confidentiality agreements. So this being said, there is a activity escalation study. You can see on the left side, this was presented at the recent ASCO. You can see that the dose is escalated to different parts. We are now in the part 2, the dose expansion. The inclusion parts are also shown here. These are patients who had at least one novel antiandrogen therapy and one prior chemotherapy. And the exclusion criteria, I think, is important to see because patients were not allowed to have previously radium, strontium, samarium, or radioconjugate therapy, which also includes, in this case, PSMA therapy. So this study is ongoing for quite some time. I cannot tell you much about it then that we really hope that in 2025, the phase 2 with the potential option to expand to phase 3 is starting. A second target we have heard a lot about in prostate cancer is the gastrin-releasing peptide receptor. There are a couple of different compounds. One of them actually is also in the hands of Novartis. The one I'm here referring to is work from our good friend Andrea Egaro from Stanford. He worked quite diligently on gastrin-releasing peptide receptors. And this is one of the few studies where you really compared PSMA and GRP head-to-head. And these are 50 patients, and what you see is that actually there is some complementary information. Nevertheless, when you look at overall lesions, there are more lesions which are PSMA positive compared to lesions which are GRP positive. And also when you look where it's mismatched, you can see that there are actually, in parentheses, only 7 lesions in the 50 patients which were GRP positive but PSMA negative. So the distribution, when you look at it, is very similar if it's going to be a lymph node or local recurrence. There's a recent paper on this, I think published last week in Lancet Oncology, comparing gallium arm 2 in primary staging compared to MRI. But I think it's a long way to establish as a diagnostic tracer. Interesting, there's also some work regarding therapy. This is work from the Rostow group in Germany, Bernd Krause and his team. And the reason I'm showing it is quite interesting because it also performed some dosimetry. The numbers are very small, but what you can see there is, first of all, we do not see any tumor dosimetry. So they really only look at healthy organs. When you look at the organs, one of the problems of GRP were very often the expression in the pancreas. And you see here the dose, in average, is 1 gray per gigabecquerel, knowing that the limit is around 40 to 48 gray. When you talk to FDA, this gives us the opportunity to give up to 48 gigabecquerel. So technically, it's not really a limiting factor. Kidney dose is around 0.3 gray per gigabecquerel, which again shows us that gives us plenty of space to perform potential therapy studies. However, we know that the amount of patients who really are GRP positive and PSMA negative is very limited. And the few patients which were shown here, and you see one of them nicely showing uptake up to 69 hours. But overall, the response numbers we have seen are not that groundbreaking yet. Again, we heard about tandem therapy, so we could also think about potentially not only switching radionuclides, but potentially also switching the targets in the same patient group. So now switching to areas of even less evidence. I care a lot about FAP. That's why, of course, I show a little bit about our FAPI-PET data. So we have a total of 10 patients. The 10 patients, when prior to PSMA ligand therapy, follow the Mike Hoffman concept. They get FDG and they get PSMA PET. We also have, in addition, an imaging study for gallium FAPI opens. That's why we had a couple of patients who were also included in this study. So we have a total of 10 patients. We performed all 3 PET scans. Then the PET scans were discussed in the multidisciplinary tumor board, and then I've discussed which of the targets were predominantly expressed. If it's PSMA, then of course the underwent PSMA ligand therapy. If it's not PSMA, we discussed either going to chemotherapy or potentially also FAPI-directed ligand therapy. Of the 10 patients, again, if you have only 10 patients, it's easy. We can really transparently display every PET scan. And you can see the left patients on the left, they have a PSMA dominant pattern. So these are the patients where FAP did not provide any additional information. Patients very straightforward went to PSMA ligand therapy. And then you can see actually 3 patients on the right where we do see a mixed pattern. A mixed pattern because not all lesions, I will show you in detail, which are FAP positive are automatically PSMA negative, but also the other way around. It's not that it's clearly adding information. So now when you go at the lesion breakdown, you can see that especially for the distal metastasis, you can see that FAPI has a higher likelihood to be positive than PSMA. If you go in the lesion-to-lesion breakdown, and I want to focus on the second part of this table, where you can see that only 5% of overall lesions were PSMA negative. And if you look at this 5%, which equals to 22 in 450 total lesions, you can see that the predominant number of lesions which were PSMA negative and still detected in either one of the PET scans were actually FAP positive. So in this case, 4% of the 5% were FAP positive, but PSMA negative. Now, giving you a quick example of a patient. There's a 60-year-old patient with metastatic CRPC, primary diagnosis 2019, had all the therapies which are needed to consider PSMA ligand therapy. As I mentioned, he had the PSMA 1007 and the FDG PET as part of clinical routine. In addition to this, the gallium FAPI PET scan. And here is one of the examples with a mixed phenotype where you do see a number of additional lesions depicted on FAPI PET compared to PSMA, but even more lesions partially seen on FDG PET. So, and the interesting thing is this patient, so also the patient I chose you to show you, is because we were able to actually biopsy some of the lesions. And you see this as part of the biopsy study, and you can see actually the part which is FDG positive is actually the part which is dedifferentiated, and the part which was still PSMA positive is the part which was on histopathology just poorly differentiated. Another target we talk about a lot is, of course, somatostatin 2 receptor. These are now cases really from real-world clinical life. It's like we don't have so far a study open. The Novartis study is coming soon, but not open yet. So, and what we do is when the patient has neuroendocrine differentiation, we actually perform sometimes an additional DOR-TOX scan. And these are actually now 2 colleagues. Again, colleagues are the ones which very often are open for new things or really want to see this. So we performed this patient a gallium DOR-TOX scan. We performed the PSMA scan. So it was a neuroendocrine differentiated tumor. You can see primary diagnosis, and you can actually very nicely see that despite the neuroendocrine differentiation, we saw much more PSMA uptake than we saw actually somatostatin 2 receptor uptake. And this was also afterwards actually confirmed in the histopathology. Another example, this is now, this is actually now not the colleague, but the father of a colleague. And 84 years old, still pretty good standard, health standard, and you can see G3 neck tumor. And he actually asked me, can you perform PRT in this patient off-label? I said, we can do this, but let's first do PET scans, PSMA PET, FDG PET, and DOR-TOX PET. And you can very nicely see that despite the histopathology, the patient has a very nice PSMA expression. So it's again a patient where we would say PSMA is predominant. And this patient underwent 4 cycles of PSMA ligand therapy, and you can see that he actually benefited very, very well. This is one of the patients where, again, after 4 cycles we stopped. patient is in good health, and we save additional cycles in case that he progresses or shows any signs of clinical progression. So pretty much in time, my summary, PSMA definitely opened the Pandora's box in prostate cancer. There are multiple new targets currently explored. HK2 is the most advanced. GRP is in a small group of patients promising. We need to find the right niche. Regarding other targets, it's too early to tell. And while I show you the last slide, I want to say thank you very, very much, especially for Michael Hoffman, but also for Annette and the fantastic Peter Mac team to make this happen and for letting us be here. Thank you.